Hello, I'm Peter Judge from DatacenterDynamics, and I'm here at Cebit, where I'll be talking to Kushagra Vaid from Microsoft about a development which could have some pretty profound implications for data centers. Kushagra.
Hello, Peter. Good to meet you.
So, it's about the power supplies, isn't it? Or more about the uninterruptible power supplies.
That's right, yeah.
And as I understand it, last week Microsoft announced a new version of the Open Cloud Server specification, which you're sharing with the industry, and which could, you're telling us, could actually save a quarter of the space in a data center.
That's right. Yes, so last week at the Open Compute Summit, we introduced this new technology we call LES for local energy storage.
Yes.
And essentially it's a power supply with a built-in battery.
Right.
So the idea is that in a traditional data center, there are big rooms with lead-acid batteries, and there's UPS control systems. So we have this new design that can completely eliminate all of those traditional design requirements. So in fact, I have one of them here right now with me.
Right.
This is the unit itself.
Right.
It's a common slot power supply, so that it interfaces with industry standards.
Yes. Anyone who maintains servers in a server room will say that looks pretty ordinary. It's just a power supply.
That's right. But the magic is there's two things inside. One is the power supply itself.
Yes.
And the second is an array of batteries.
Yes.
And the batteries we use are these types. So this is a little bit bigger than a AA battery.
Yes.
It's called 18650.
Yes.
It's a commercial lithium-ion cell that is used in extreme volume in the power tools industry. So if you know about the hand drills and the electric cars, it's the same battery that's used in those industries.
So they're massively reliable.
They're massively reliable. There was over 100 million of these batteries that shipped last year.
Right.
It's been tested for extreme conditions. It's low cost.
Okay, and so the idea is if you've got, instead of having one room full of lead acid batteries that's your UPS, you distribute the UPS so that every server has its own little bit of battery. Now, that's not entirely new. People have tried that to some extent before.
That is correct, yeah. The people have tried putting UPSs in racks.
Yes.
The big difference here is that the previous designs used to be an inline UPS.
Right.
In the sense that the electrical current would first go into the UPS, and it would then go into the IT load.
Yes.
Now whether that was done at the data center level, or the row level, or a rack level, it was still inline.
Yes.
What we have done here is we have put the batteries in parallel to the bulk capacitance that is inside the power supply.
Right.
So it's essentially a new power supply design with pretty much 99.9% efficiency.
Yes, it's massively simpler. Instead of backing up the IT load, you're backing up the capacity inside the power supply, which you already have.
Which you already have.
I think you're going to have a job convincing IT managers of the benefits of this thing you're offering. So tell me again what the benefits of it are.
I would quantify the benefits in three numbers. And the first one is it's a 5x cost reduction versus a traditional UPS design.
Right.
The second one, and I'll go into details of how. The second one is it's a 25% reduction in the facility footprint, which can be up to $30 million in savings. The third one is it's a 15% improvement in PUE.
Right.
So these are the benefits from a CapEx standpoint. Now there's some other benefits if you're an IT manager. Essentially now you can add UPS capacity on the go.
Right.
So unlike a typical data center where you provision the UPS room even before a single server goes in, now as you build out your server capacity, you can add your UPS capacity.
Every server brings a bit of UPS in with it.
Every server brings a bit of UPS.
Okay, and so the 5x cost reduction, that's because these commodity batteries are cheaper, is that right?
Yeah, it comes from two pieces. One is the commodity battery itself. The second piece is essentially because The traditional UPS designs they're big to maintain.
Right.
Usually they're not reliable enough to take on the failover load.
Yeah.
So most data center operators install a dual redundant pair of UPSs. Then you have an ATS switch that enables you to switch back and forth. So essentially we are getting rid of all of that infrastructure.
Right. Yes.
So that's where the 5X comes from.
Yeah, and I've got to say this now, but when Kushagra says these are commodity batteries, they really are. He was showing me his red battery the other day, and I went away and dropped my. I've got a UPS. I've got a USB hub here for charging my phone. I dropped it. The lid came off, and inside I've got 2 of these just exactly the same batteries that are inside Kushagra's box.
Yeah, these, we got some numbers on the batteries, and there's over 100 million that shipped last year.
Right.
And with the car industry going more to electric cars, it's expected to become even higher volumes.
Right.
So we'll ride that commodity curve down and get the benefits of the cost savings.
Okay. And the 25% space savings, that's because every data center has a big room full of batteries.
Correct. Yeah, in fact, there's 2 big rooms. One is for the batteries themselves, and the other one is for the UPS controls.
Right, okay.
So the math we did was the combination of these 2 rooms in a typical data center is about 150,000 square feet.
Right.
And at $220 per square feet for the build cost, if you do the multiplication, it comes to about $30 million in savings.
Yes. You're not replacing the diesel gen sets, are you? They still need those?
You'll still need the diesel gen sets.
Okay. And the PUE improvement, that sounds very impressive, and that's because of simplifying the power distribution, is that right?
Yeah, it's because of that, and it's also the recharge. So in a typical UPS, you have to reserve about 8 to 9% of UPS capacity for the recharge. In this case, you have to reserve no more than 1%.
Oh, perfect.
So that gives you the big boost in PUE. And the thing is, at a time when there's a lot of pressure on IT budgets and efficiency improvements, getting a 15% PUE improvement is very hard, but this is an easy way to get there.
Yes, excellent. Good. Thank you very much.
Thank you, Peter. Nice meeting you.
Right. Thanks.